In the previous module, I covered some of the basics of examining Apex code and understanding the content of an object transaction. Among the options you have for doing so, especially as it pertains to governor limits, include debug statements, the limits Apex class, and the analysis view in the Salesforce Developer Console. In addition, and while this is outside the scope of this course, there is also the Salesforce Apex debuggers, which include the replay debugger that utilizes Salesforce logs, and the interactive debugger, which receives events from Apex during execution in an org. All of these can aid in understanding the content and structure of a given object transaction. At some point, after months or years of development, an org can end up with super bloated object transactions, where Apex triggers can contain a large amount of instructions. There can be flows and other automation intermingled in the object automation, and more. While Apex allows up to 10,000 milliseconds in a synchronous transaction, the truth is that even 3,000 milliseconds, or 3 seconds, can be too much and cause the user experience to suffer. Some users will feel that the system is broken or lagging behind what's expected when pages take longer than a few seconds to load. At some point, the decision can be made to offload some of the work being done in object transactions to asynchronous activity. The trade-off, of course, is that there are limits to how many async jobs can be enqueued, as well as how many are running actively simultaneously. In general, a high volume of Apex also translates to other drawbacks to how Salesforce testing and deployment works. It will lead to longer deployment times when deploying changes to production, longer periods to wait for Apex tests to complete, and that translates to longer development iterations overall for running tests across the org to ensure that nothing is broken from the standpoint of regression. So at some point, it can make sense to consider the overall size of all of the Apex and consider taking some parts of the logic off-platform. For each object transaction, an evolution can occur. If imagining a spectrum of solution options that range from requiring less speed, less memory, and less flexibility on one side, to the other side needing more resources, development might begin with leveraging point-and-click automation via Flow Builder. Of course, following Flow Builder, there may be some requirements that demand logic go into Apex triggers. For most of what has been covered in the prerequisite Apex Academy courses, and so far here in this course, this is where the solutioning ends. But of course, once Apex triggers have a certain volume of logic, it leads to longer running times, or leads to expensive computational requirements, and then that may mean breaking logic out into asynchronous Apex. Asynchronous Apex also can be where the solutioning ends, of course, because it may give the performance needed. There are a variety of reasons to choose asynchronous Apex, and not all of them are related to managing performance or staying under governor limits. But in this case, I'm mostly looking at this progression from that standpoint. Then, finally, it may be necessary to go off-platform. I'll talk about all the reasons to build logic off-platform momentarily. As a high-level overview of asynchronous Apex options, there is first the future method. The future method is the simplest and perhaps easiest to implement. All one has to do is annotate an existing method with the @future annotation and ensure that it only has primitives as input. From there, you may need to worry about having the method query the database for any data that it needs to act upon. For example, you could have a future method take a set of IDs and then use that set of IDs to query an object for processing some of its data. Then, the queuable job. The queuable job allows actions similar to a future method, but it's more robust. You can pass in any number of input types, including custom classes and S-object representations. At the end, you can enqueue yet another queuable job to run for continuing processing too. As long as the solution allows that processing can happen over a longer period of time, you can keep chaining actions to ensure the class stays under allowed governor limits. Queuable jobs are probably my favorite async Apex option because of their versatility. On the downside, you have to define them as an entire class instead of just a method using an interface, and that's a little more setup than the future method. But the advantages far surpass the disadvantages, in my opinion. Then, event-driven Apex in the form of Apex event triggers, which can either respond to custom platform events that are broadcast on the platform, or change data capture events, which allow for full-blown asynchronous object triggers. Beyond asynchronous Apex, it may be deemed necessary to write logic that runs off the Salesforce platform for a number of reasons. The first is infinite loops. Much of the Salesforce developers' time is spent making sure that infinite loops never happen. But what I mean by this is perhaps something like an event listener that is always listening for events, or perhaps an autonomous agent that runs on a server and perpetually updates its state based on different conditions, such as an infinitely running finite state machine. Third-party libraries, which of course might mean libraries that are referenceable in your favorite language, things like Node.js, Python, Rust, or C#. There may be libraries that are easily built upon off-platform that Apex cannot interact with easily. Advanced graphical processing, like video encoding or post-processing, 3D modeling tasks such as those with CAD files or 3D object meshes, or perhaps processing that involves advanced machine learning tasks that run on graphical processing units. Building off-platform may also simply be managerial preference. Sometimes the old guard has an opinion about their favorite technology, or they make decisions off of office-grounded politics. It may not always make logical or rational sense, but hey, it does happen. And you might still be tasked with figuring out how to take something that used to exist in Salesforce and figure out how it's going to run on another server. High performance. I mean, like extreme performance. Apex, for example, is a language that doesn't involve manual memory management and is designed to work with a certain degree of safety within the confines of the Salesforce technical architecture. There is no breaking out of those limitations unless you go off-platform, maybe having to write something that uses memory-managed programming languages, processes that must run on-premise for some particular reason, or other performance demands. Big data, like really big data, in the order of hundreds of millions of records. Salesforce can scale quite large for many applications, but giant databases with hundreds of millions or billions of rows might require capabilities Salesforce does not provide. Energy companies and their production data are usually good examples of this, because there are instruments that collect environmental information on the order of every few minutes on tens of thousands of devices, and that translates to lots and lots of rows of data. Obviously, building off-platform, especially if you're used to only working with Salesforce, is a giant body of knowledge by itself and is outside the scope of this course. It's worth noting that it does have some use cases that certainly apply sometimes. Let's get back to Apex though, and talk about some of the fundamental differences between approaching these async Apex techniques in the next clip, where I'll dive deeper into why you might want to use one of the options over another.